So, I'm going to go ahead and start. So welcome to my talk. It's about GNU Radio in 2019. The world has changed. Let's change GNU Radio. What we're going to do in the next 40-something minutes is basically we look back, but I'm going to keep this really, really brief, on the last 5 years of 3.7, which come to an end, I think. That era will be over soon. Then we'll talk about what happens next when we'll actually release 3.8 and how that'll happen. We talk about what happens afterwards, and I guess a lot of the things that will be interesting to most of you will be the Q&A session. So I'm trying to kind of rush through this so that I can actually take questions. So let me get started really shortly. I was actually going to skip that slide, but I added because just last year at FOSDEM I became the chief architect of GNU Radio. So now I wear like several hats. The guys that basically paid my hotel here, like I support, I supply grumpiness to the active support. I'm also like a research assistant at CEL, at Karlsruhe, which makes me proud that my former bachelor advisor did a quick talk on information theory here. And aside from that, I basically freelance. And I said mainly I'm here because I'm the chief architect of GNU Radio. So let me talk about GNU Radio. So GNU Radio, you know, the version that you probably use if you install GNU Radio in some binary form is 3.7 something. And 3.7 has been around for quite a while. We basically never got around to increasing the minor versioning number. 3.7 has been around since 2013. And somewhere around this time, like somewhere late 2014, the next branch was actually, branched off the master branch to develop the next version of GNU Radio, which was to become 3.8. And then there was 5 years of 3.8 in the making. And you can imagine that if you have two branches, one being the master branch from which you basically do nothing but release compatibility versions, and the next branch where you do basically everything but can't really agree on which direction to take, this is going to be like a really complicated time for the project. So this really took a long time, and we finally gotten around to merging the next branch back into the master branch, which was a great task, and I'm really thankful for Andre, Martin, and others helping me with that. I wouldn't have been able to do that myself alone, definitely not. But the state we're currently in is that we have the last 3.7 releases have been of a main 3.7 branch, and everything that happens on master is towards the future, towards 3.8. So that's where we are. Our last 3.7 release has been a while in the past, and we're getting ready to get 3.8 out the door. What happened in 3.7 since basically I took over is, first of all, I introduced semantic versioning. That was kind of long overdue. I also kind of formalized the changelog format. That was my thing. And as said, we retired the idea that we have a next branch that is supposed to be the next great thing. And we all mainly do on backports. We kind of do everything on master now. And for releases, we have a maintenance branch that has the release in its name. And for example, 3.7.14.0 would be tagged of main 3.7, not of master. So with that, we're kind of accelerating development of GNU Radio that actually has worked out. We've got a lot of things that were in the pipeline for a long time merged in during the last year. So I'm very happy about the speed that all this has taken up. With me talking about releasing 3.8, obviously everyone that's using GNU Radio productively, there's people running, satellite ground stations of this, they might be asking themselves, well, are we going to support 3.7 for any longer then? And the honest truth is we've been supporting this for 5 years. And everyone knows that if you're doing software long enough, then every single part of its behavior kind of becomes API, whether it's documented or not. So yeah, we will be supporting that for a while longer. I can't actually give you a timeline for that, but to be honest, like, it will probably be as long as, like, my least favorite distribution, Ubuntu 16.04, will be supported, because that's basically the thing that holds up, like, has all the dependencies that still apply to that version. So once people can't compile that reasonably on their modern machines anymore, there's really no point in us supporting it any longer. If you want to contact me and say, hey, I run big software on that, I'd like to help you support 3.7 in 6 years, I'd be very happy, but I honestly don't see that happening. So for now, I promise that we're not going to drop 3.7 soon, but I promise that we will at some point move on with our lives. But what that means is that 3.7 will never be Python 3 compatible. 3.7 will never be C++ 11. 3.7 will not get any of the cool new, more fundamental features that 3.8 has. If we're doing bug fixes on 3.8, there's a high chance that we can backport that. We'll do that. I've been doing that in the past. But there's only so much time. So if you've been working with 3.7 for the last 5 years, chances are all the bugs that are in there have already been fixed by you or not noticed by you. So yeah. So enough chatter about 3.7. What's all this 3.8 about? This is kind of like the conclusion of my talk at GRCon this year. So I'm going to keep this rather short. If you want to know more about that, I think the GNU Radio conference videos are online by now. But I really want to, I hope so. I'm actually not sure. But to highlight a few things. So the main reason that we need 3.8 is really that, Python 2 is no longer an option. Qt4 is no longer an option. So we had to move forward with these dependencies. Cheetah has been like kind of dead. Also, it's only Python 2. So our core XML parser for like GRC has gone away. So we had to reinvent a lot of stuff. So all the green dots here are happy faces in my head. We have one dependency progression, like log4cpp is becoming more and more problematic. We'll need to replace that. Also, we need a better logging system. And it's not easy to adapt other logging systems to ours because, well, we have specific multi-threading needs. We have specific problems with runtime, discovering of subsystems. So this is going to be interesting. We threw out a bit of stuff. So to anyone who's using grcomedy, I'm kind of sorry, but I know any of you. So if you need that, please do contact me. I don't care about it right now. If you need it, we'll keep it. But so far, I have not met a single user, so might as well not keep it. Code quality is questionable because none of us understand what it does. I do want to highlight a bit of like this. This is all the opposite of exciting, right? This is all like maintaining stuff. This is all about, painting the walls that become slightly gray. Like the interesting stuff is like one shout out I want to do is like to Swapnil, who's sitting in the corner over there, who's actually come from India to here. He's been doing the Google Summer of Code for us this year. He's been improving grmotu, which has become way more easy, like nicer to use, has better code structure. So I'm very thankful for that. It has new features like proper detection of blocks that I'm very happy about. Then we also have Håkon, which I've seen. Oh, sorry. Yeah, he's also here. He's been here last year too. He's been doing GSOC the year before. Now we have C++ code generation in GRC. So you're used to GRC. When you hit the run button, it generates a Python module and like Python program and executes it. We can now generate C++ code, so you can compile, cross-compile, and run it on your toast or whatever. And the feature that like I like by numbers most users will be interested in is like that GRC has overall become way nicer, way cooler. What I mean with that is that you can actually have like the canvas now is a vector-based canvas. You can actually export PDFs, which might be interesting for people who put things into printed publications. And also like the code base really looks a lot nicer structured inside. There's a lot less duplication of functionality, cleaner abstraction. And I hope that's really a big hope that this enables every one of you who like probably will find a bug in GRC because we have so many that everyone can get a free one. That enables you to just go in and say, okay, this is easy. This is just Python. I know Python. Let's fix that. So that's like the exciting things that happen in GRC. So these are like the main selling points that I have for 3.8, aside from the whole like being nicer to forward development things. So this question has basically been asked, well, like years before I even became maintainer. When will we release 3.8? And the honest, truthful answer is when it's ready. And I promise we're not going to do it a minute later. Like the day it is ready, we will release it with all like taking care that it is actually ready, but we will release it as soon as possible. What we'll not do is like release it a month earlier, because that means that someone's going to ship a broken system, and we're not going to get that out for years. I do have like a few blockers to highlight here. First of all, like there's been ongoing efforts to modernize the CMake we use, which is led and basically done by Andre, which is very important because it makes detecting certain libraries with like the standard tools possible at all, and B, it makes using GNU Radio in your own projects way easier and way safer. So this is really something that I want to get out there with the 3.8.00 release, because doing it any later only will complicate things. So this is already orange. Like you can't tell this on this beamer, but this thing is actually work in progress. This thing is something that we've not even tackled yet. Why? Well, it depends on the first one. What new OOT template means is that right now we are expecting you, as GNU Radio users, to, well, use GNU Radio and write cool SDR software with that. And most people do that by having their own out-of-tree module. But having your own out-of-tree modules wouldn't be possible if we, in the past had not have a template to work from, where even like GR module is actually just the tool to take that template, customize it for your purposes, and then add the functionality that you use it, just so you don't have to write boilerplate code. And we don't have that template yet. So that's kind of a blocker, because if I put out GR 3.8 and no one's able to actually like write software for that, then adoptions will probably be about 0. Then I mentioned log for CPP, so we have to re-implement the logging system. This is going to be fun. There's specific industry needs that need to be addressed. We know the people that are actually willing to help us there, to contribute there. But we need to like come up with a reliable infrastructure idea at least. Then we also have like a lot of bugs that are simply like, oh, this crashes in GRC, for example, and like some of them are really just blockers. So we need to fix those. And like this, like I came up with this like last minute yesterday night. Obviously, this belongs into the same category as an OOT template. People have not only have the tools, but also know how to use the tools. So we need some documentation. We need to update our tutorials, this kind of thing. So this is a bit of a shout out to Mark Lichtman, who has been like our new documentation officer. He's very motivated, but we've like not been able to actually like nail down how things will work, so that we can tell it to newbies. So yeah, that's something that we need to come up with. So if you want to help with that, because you're really eager to get GNU Radio 3.8, and I can see in all your faces that you definitely are, do go to like our GNU Radio GitHub repo, click on projects, and you'll see the release 3.8 project. And what you'll see is that we have open issues, issues that are work in progress, and a lot of closed issues. So do pick one of the open ones and comment on that, or fix it. I probably prefer fixing it, but to be honest, like reproducing a bug is really, really helpful for a lot of things that we simply don't know whether they're just broken on that single machine because someone fiddled around with something else, or are actually broken. So go into that project, find an open problem, or go into our 248 or something issues that are still open, and read through them. That would be very helpful to me, and yeah, that will like help me answer that question sooner. So assume we have fixed all like the open things. What will we do? Yeah. So after we got the blocker sorted out, I'll go in and tag release candidate 1. What will that mean? That will mean that I have something that I believe runs on every computer that should be running in radio. Realistically, there will be bugs. So what we need to do with that release candidate is get it out on the street. So what we will do, and that's a new, like something that we've not been overly good at so far, is like have our own binary packages with that, so that people can actually, add, like if you're on Ubuntu, add a PPA. If you're on some Red Hat or it's add like the YAM source. If you're on, I don't know, Mac ports, I do the appropriate thing and just get GNU Radio release candidate. So then we'll wait some time for the bugs to trickle in. That will be like, that actually depends on which time that happens. If it happens around like someone from the core team doing vacation, that might take a week longer. But let's say this time frame was here 2 to 3 weeks. After that, after we think that most of the bugs have been fixed, we will do something that is super nice to me. We will just apply Clang format to the whole code tree. Because if you've been looking at GNU Radio core code, then you will notice that there's a lot of personality in the way indents are used, or a lot of, well, freedom in the way people put braces on lines and things. So that automated code formatting will be a single commit, kill all thing, which will hopefully not break anything. I'm pretty sure about that because, the Clang people tend to know what they're doing. But yeah, that'll probably like allow us to release candidate 2, and at the same time, we can branch off the main 3.8 branch and start working on master for the 3.9. So after we release our RC2, we like wait another 10 work days to let the latest blockers come in, if any. Then we'll release 3.8.0.0, and then we have a party, which probably consists of me having a barbecue or something. That's like, I hope to like raise a bit of a feeling of transparency here. It's like, we're all sorry that it took forever, but we're trying to be like pretty forward about getting it out the door. So, what's going to happen once that we have 3.8 released? Yeah, well, as mentioned, we'll have a main 3.8 branch from which like 3.8.1 or whatever will be released. So this is the place where bug fixes for that release will be on. On master, we're not going to develop for 3.8. If we decide that a feature is cool enough to be part of 3.8, we'll gladly backport that. In the beginning, it will be super easy. But later on, we'll focus, like master will only be future development. So this is 3.9. We'll not have next branch anymore. So master will be 3.9. But as promised, like 3.7 point whatever will still be around. We'll still care for a few years. But that at the moment, it's mainly like a single bug fix per month or something. So there's not going to be a much of traffic on main 3.7. Okay. So as mentioned, 3.8 is kind of a housekeeping release, a keeping my car running so that I can still run errands release. It is also a transitional release. In what way? We put a lot of effort in, maintaining the ability to still use Python 2, which is really unusual for projects. Most projects that needed to let go of Python 2 just switch over to Python 3. We didn't do that because we anticipated that people would want to port their out of tree modules to a newer GNU Radio version, but didn't want to rewrite most of their code if Python 3 breaks that. So we still want to enable people running 3.7 to on the same system build 3.8. So that's why we're doing 2.7 and 3. Whatever in parallel on GNU Radio 3.8. But we will not do that afterwards because it's really a lot of effort. But we see it as the golden bridge, making your out of tree module future-proof. Is okay, port it to 3.8. That basically takes care of all the architectural stuff. And if you want to port it to Python 3 on the way, that would be cool. We'd greatly appreciate that. If you don't, do it later. But be aware that 3.9 will be Python 3. So 3.9, is the thing that I'm most excited about right now because it's getting so tangible right now. First of all, I kind of mentioned that multiple times because it kind of is exciting if you look at code a lot. After we code formatted the whole thing, we will be able to, we're obviously going to stop having that feature freeze that we have right now, focusing on 3.8. And I promise, and this is really very dear to my heart, it's we're not going to take another 5 years to release 3.9. We need features to be available sooner. So, that's how we'll, directly after we release 3.8, we'll start working on 3.9. And what will this entice? So what are the bigger scale plans that I have for the future of GNU Radio? Well, first of all, I want to be more inclusive in two aspects. First of all, I feel that GNU Radio should be more it is the core of your ecosystem and should work out of the box for a lot of purposes. So, the usual user of GNU Radio starts with an RTL dongle or a HackerF, or probably not anymore with a user P. So you guys start installing GNU Radio and then compiling grosmo SDR from source, which is fine. I like grosmo SDR, but it's an additional burden to you as users, and it's not consistently packaged, and things get outdated. And so this is not something I want to keep that way. So I think that GNU Radio should come with batteries included. Then the other way around means that if I want the ecosystem to work for everyone out of the box, that I have to care about the ecosystem, right? So what I'm going to do is consider things that I see as central infrastructure and upstream it. So, well, there's a lot of people that have GR bus out there, or GR foo, that basically has some wrappers, some stream operations that they reuse in their own IoTs multiple times. And that's all functionality that should basically be in GNU Radio. And we should also notice when it breaks. When some architectural change breaks GR phosphor, that would be kind of bad. But we will notice until someone wrote an email to the mailing list that says, hey, I've tried 3.8.40.0, and now all my collars are inverted, and my dog started barking. So that's something that we need to have, be more of a umbrella organization that actually builds your code too and tries that. So that means that we'll have more things in tree. Then, as I basically try to line out, obviously we need to be more future-proof. So we need to, and that's easy to say for a maintainer. We need to track dependencies more aggressively. We need to be oh yeah, whatever, Qt5 is going away in a year or so. It's not happening, but Qt5 is going in a year. So let's not base our new 3.11 on Qt5. Let's be more aggressive at adopting newer dependencies. That only works if we're doing a more regular release cycle. So this is an interesting aspect. That also requires us to be very clear about how long we're going to support things like 3.8 or 3.9. So that's something that we need to come up with a clear strategy for. Also, what that means is that we remove all burns and replace them with new ones. With modern alternatives for problems that we're having right now. I could name quite a few of these, but I'll go into that in detail in a minute. What we also need to do, and that's kind of obvious, like we had a Birds of Feather meeting yesterday with GNU Radio users, and a lot of these were single-time users, new users, would like to be users, and it turns out that installation is a major obstacle still, like in 2019. Imagine that. People can't just use like a binary package to get like the recent version of GNU Radio from the development tree. We have no nightly builds. We have no binaries that are outside like every distro's maintenance scope. So that's something that we need to change. So personally, I have this dream where like I don't only have a nightly version of GNU Radio somewhere like whatever, a PPA that ships nightly versions of GNU Radio, but also like nightly versions of GQRX, because that depends on GNU Radio, and nightly versions of GRAAS, because tracking ships is cool, but it depends on GNU Radio. So that leads me to like a zoo of IoT binaries that we would need to build like on a regular basis, which would kind of make PyBombs obsolete, which I think is a bad thing. But yeah, that would be pretty cool if I could just go and say apt-get install, gr my latest module, and people would get my latest module as binary. And obviously, better docs. Well, obviously, you can always document better. I used to be feeling bad about GNU Radio documentation, but especially Brandon's talk opened my eyes towards like the badness of other people's documentation, and I'm getting less and less apologetic about our documentation. We just need to be more clear at the basic level so that people are able to research stuff themselves, and we don't need to like document the hell out of every single block. So that's an easier task, less daunting than I used to think. And lastly, we need to be better overall. Like obviously, like GNU Radio has been a great project for like 15 years. Like no, 17 years by now. But that also comes with like some technological debt. We have basically we can't exchange our scheduler right now. There is this thread per block schedule, which is kind of cool if you have about as many threads as we have blocks. But most modern machines have like 4 to 32 cores, and like a single balance flow graph has like 200 blocks. So you might see there's some mismatch here. So we need to be clever about the way we schedule things. We need schedulers to be able to adapt to the problem and to the platform they're running on. Then we have this problem where GNU Radio is really, really focused on running on one and the same machine. But in reality, GNU Radio should be a framework for connecting blocks and doing signal processing, right? So it would be super desirable to be able to, have few blocks run on my laptop and then have this block somewhere in the cloud running like the LWC decoder, because that's super, super compute intense. And that's actually what like mobile network operators are doing. They're running more and more of their software wherever that's the cheapest thing to do. And that's somewhere we need to be, but that's really hampered by the fact that we share state between blocks. And this is sadly not limited to samples that cross in buffers. That's also implemented by things like having an equalizer that both my OFDM receiver need to modify and the OFDM equalizer block actually needs to use. So we need to have the ability to pass messages with info and be more RPC oriented overall. Currently, our RPC framework is basically broken. I gladly admit that. I see a grin over there. Yes, it is. We need to like re-implement that, and yeah, thanks, Martin. Yeah, that all boils down to actually writing a new scheduler. So that's like a very rough idea where I want to take things. But hey, having such plans is awesome. As we all know, we're not like kind of 300 people per company that dedicates their time to development. So how much of that is going to happen in 2019? So I can gladly say that we have laid the foundation for every single one of these points. We're not able to tackle, like, finally solve any of these in 2019 completely, but like what we'll do is for 3.9, and I'm very happy to say that we'll be able to upstream GR SOAP. So like thanks to the cooperation with like the developers and especially Libre Space Foundation, we can make your favorite SDR work with GNU Radio out of the box. That's kind of true. You still need like the respective SDR driver, but the fact that SOAP is basically a plug-in based architecture so that you can load a shared object at runtime means that at installation time of GNU Radio, you don't have to have like your HackerF driver already linked into that. You can load it later on, and that's a very nice thing. It enables us to like more aggressively develop features instead of trying to, having to link to every single hardware driver that might be there. We'll also upstream GRIO, which is kind of special purpose. This is I kind of view this as a test balloon, because GRIO doesn't make too much sense on a PC, as far as I can see. I hope the ADI guys will correct me. It makes more sense on SoCs. It makes sense if you're like building something with an AD chip on it. And obviously embedded compute is something that we want to be more in. Like I think that's where a lot of the future of GNU Radio will happen. It's less on laptops of academics that do simulations. This will be more on devices actually doing network stuff or satellites. And as said, that we also have like a lot of interesting options that we need to upstream about better networking blocks. So that's what we do about being inclusive for 3.9. As said, to future-proof 3.9, we can drop Python 2 compatibility. Like there's no distro in the future that doesn't have at least Python 3.5 that I care about at the point that we'll release 3.9. So we can completely drop Python 2 compatibility. We can drastically increase the CMake version that we depend on. That's very nice, because CMake is kind of a nightmare to use the older it gets. And this is like the biggest point on this slide is very clearly we have a problem with PMT. PMT is our internal library for exchanging data objects in messages and stream text. And I know where it's coming from. It does a fairly okay job at being what it is. It is a polymorphic type to like, I can put an integer in there, I can put a dictionary in there, I can transport sample data in there, but it's all it is slow, it is kind of awkward to use, and mostly it's buggy in the way it's wrapped into Python and C++. And and also it's our serializer, with the downside that it's not actually portable and there's no language support aside from Python and C++, which happen to be the languages that you could natively talk to GNU Radio with. So, so we need to get rid of that, enabling us to actually come up with a better RPC basis, because RPC won't work if you don't have a way to share data. So then we have the simplify aspect. I already mentioned that we need to have binary releases. I don't know if they're going to be nightly. We're not that fast. Maybe weekly would totally do. I guess somewhere in the middle. But we're going to figure that one out. We're also going to do, I mentioned the template for out-of-tree modules. That template should have like the minimum infrastructure to make it easy for you to like create a Debian package or a RPM. I actually don't care, preferably both, so that you can, distribute this to your potentially customers. Like I hope that people will use GNU Radio more in commercial deployments like they should. Less, oh, I compiled this on my machine and then I SCP'd that over. Then I talked about bettering ourselves. I don't think this is gonna be complete in 3.9, but we're gonna start with having RPC in every aspect of GNU Radio. So there's no reason that we should have setters and getters and blocks that can't be called remotely. That's just like our heritage and a bit of our laziness. So we need to start working on that. And this is making me very happy. A lot of you guys probably know Woke as our library of SIMD operations. And it's basically meant to be a spin-off of GNU Radio. What it is in reality right now, it's like its own GitHub repo. And that's being a submodule, like Git submodule, actually in GNU Radio. And that makes no sense at all, because either you develop it out of tree or you develop it in tree, but you shouldn't do both. But with us picking up speed, we can basically ensure that Woke has regular releases, so we can actually make Woke an external dependency and maintain it as its own project that it has become a long time ago. So, with that being said, let's draw a quick conclusion. We'll not let 3.7 bleed out. We'll support it for a while. I promise we will be releasing 3.8 very soon. We could use your help. We could use your coffee. But it is coming. It's not abstract anymore. We know what to do. We actually have a list of things that need to be done. And if that list has become like all striked out, we will release that. 3.9 after that is the next big thing, in that it adopts a new strategy at upstreaming, and it starts getting rid of architecture that hopefully will allow us to be, well, cooler for new users. So, with all that being said, I'm open to questions. Thanks for your attention.
Before we start questions, you mentioned Orgon and Swapmill in your talk.
Yeah.
Did you mention anyone else? Mark is not here.
Andre and you.
Okay, so those two guys get hardware. By the way, if you want to use this, you do need GRI. Right? Go ahead.
You want to use it with no radio.
What else would you use your SDRs with?
Do you have any plans for actually having more challenging latency requirements?
So the question was how to address more like closer latency requirements. And that's something that we can't do with the current scheduler, because our current scheduler simply is only optimized for throughput on a potentially infinite many-core machine. So there's no precise plans. Last year I talked with a gentleman that, and we will be addressing like scheduler constraints that will be allowing us to restrict latency, but that's not happening in 3.9 likely. So realistically, making the scheduler adaptable, like pluggable, will be necessary to, experiment with different scheduling strategies. So this first, latency later. So.
What about macOS support?
So the question was, what about macOS support? Yeah, what about it? I actually don't know what. So it doesn't compile out of the box on macOS. I actually don't know. I have never used macOS X. So I have my guys for that. And my impression is that we're actually doing a pretty good job on that. So I can only, this hasn't come up the first time at FOSDEM this year. I can only ask you to actually write that email to the mailing list or open a bug, because we can't fix things that we don't see. Maybe, I can't rule out that you're doing something wrong. I'm not willing to blame this on you, on the other hand, so please do write that email.
So we have a guy who's on Mac calls.
Okay, now we have two guys, right?
Yeah, I mean, yeah, you're more than welcome. I mean, we can set you up with whatever you need.
The radio is able to make whatever that means and also.
So, Gibby? So if there's something wrong with log4cpp, yes. So log4cpp is, first of all, like I'll be honest, I don't like it. That's the first thing. It is like a C++ part of log4j. That says a lot. It also it has recently shifted the C++ version it requires. So we're right now running with a few workarounds. So it's simply not reliable enough. Then also, and that's the other thing, we do need a better logging system. I've been at Congress. I've been talking to the Osmocom guys because they internally have a logging system for their network-oriented stuff, which is much more like what I want GNU logging to become. And putting this on top of our current log4cpp structure, that's like not really paying. So we might as well replace that with whatever is easier.
Coming to dynamic reconfiguration of flow graphs and wish list for next questions.
So the question was, what will happen with respect to dynamic reconfiguration of flow graphs? That question needs a bit of background. Currently, like if you say, dear flow graph, I want to disconnect this block from the other block and connect them in a different way. What happens if you basically stop everything, everyone grinds to a halt, and then in some more or less specified state, the buffers are reconnected. And that's a nightmare. We can't be doing that in the future. Sadly, this is very, very integral to like how the current scheduler works. So the answer is kind of the same as for the latency restrictions. It probably requires rewriting of the scheduler. I mean, if this, I'm the architect, I say probably, because I do feel I have an understanding of how the current scheduler works, but there's just too many corner cases with how it's implemented. Like there's literally too many go-tos in the source code that to allow me to predict like corner case behavior. Like what happens if I reconfigure and someone else says, okay, I'm done, and yeah. So this needs modeling. This foremost needs a modeling of how things should be behaving. But modeling existing software is actually harder than like writing software to a specification that you have made up prior based on your experience with your current software. So yeah, as said, it basically requires you to like write a scheduler.
All right, we need to.
Yeah.
Thank
So,
you again.
thank you.